this is a video regarding artificial neural networks, feedforward neural networks. This is video 2, so this is the continuation of video 1. So we are going to see how can we classify the short function with two inputs, as it is presented here, with a feedforward neural network. So these are the samples, the representation of the four samples, 0, 0, 1, 0, 1, 1, and 0, 1. So we can use a neural network with this structure here. We have two hidden neurons, and we got here the bias input. So we have another input x3, which is +1, and also in this output layer we got also input a bias. Okay, so we can evaluate the output for neuron 1 here. So we have the ponderated sum G1, and the output is the activation function with who takes with input as input the ponderated sum. We can do this also for Y2, which is this output for the hidden neuron 2, and of course for the output of the network, which is this Y, is also we can do it is this one. So you can check this out for the weights and the output. So the output is the output of the activation function, considering y1 times this weight, and then y2 times this weight, and then this +1 times this weight. Okay, the activation function here is a step function with a threshold which is 0. Okay, so if we rearrange the equation to obtain the discriminative line, we obtain this equation for the line x2 in function of x1. We can do also that for the second hidden neuron, and for the third the output neuron. Okay, so we got the three lines, each one for each one of the neurons. So we have seen in the previous video, neural networks 1, that this is true. So for this combination of inputs, we got the output is really a short. Okay, so now we are going just to see which is the result for each discriminative line for each neuron. So if we consider just this one, the output for the hidden neuron 1, this is the network that we are interested in. So if you replace the weights here in the equation, 1 here, if we put 1 here and -1 here, and -0.5 here and -1 here, so this is the equation for the line. Okay, the first one we represented in blue for the hidden neuron 1. We can do that this the same for the second one. Sorry, before that we are going to see what happens if you put here x2 equals to 0. We got a point for the line, which is this one, 0.5. And if we put this equals to 0, of course we got -0.5. So if you represent the line passes through these 2 points, this one and this one, and the discrimination is this one. So we got two classes. One of the classes, is C1, the other C2. So C1, for C1, the output of the neuron 1 is be larger than 0. So we can see that the classification for, in this case, we got for class 1 when with just one situation when y1 is 1, so it is this one, 1 0 is the first class, and the other three they are 0, so we got 0 0, 0 1, and 1 1. Okay, so these are the two classes and the samples for each class. So we can do the same thing for the hidden neuron 2 and evaluate the expression for the second line, which is this one here. Okay, x2 equals x1 plus 0.5. So if we do the same, and if we put here 0, so the first point is minus 0.5, the second point is x2 equals 0.5, so these are the points, and this is the line, the discriminative line, and so the classes are this one and this one. So if we look again to the table or to the figure, we can see that the first class just has this sample here, 0 1, and the second class we got 3 points, 0 0, 1 0, and 1 1. Now for regarding the output neuron, the equation is this one, y2 equals minus y1 plus 0.5, and if we do the same, we got these 2 points, 0.5 and 0.5. So these are the points, and this is the line. So this is important to see that here the samples are different, because if you look to the table, we can see that the inputs from this neuron, we got two samples, which is this one, 0 0, which are the same. So in this point, we got two samples, okay, in the same point, mapped to the same point, and then we got 0 1, which is this point here, and 1 0, which is this point here. So in this case, we can see that the first hidden layer just mapped the four initial samples to these three samples. Okay, so in this case we got okay, this is the class 1. Actually, here in the figure it is I have put here should be the opposite. Okay, class 1. Okay, in this case should be, as according to the figure, should be they are switched. But you can see that one of the classes we got 0 0. In this case should be C2, and the other one we got C1 should be 0 1 and 1 0. Okay. So if we put the three lines overlapped, we can we obtain this figure. But okay, we have to see that in for the red line, this should be y2, and this should be y1. Okay. Okay, and with this figure, I'm going to conclude this video. Hoping that you enjoyed. Thank you for watching.